Hello everyone. We're going to talk about triple integrals, which is from section 15.5. So the definition is similar to those in the double integrals, except the object we are talking about is going to be in the three-dimensional space, which is like this solid. So the triple integral f over d is defined as, this is notation, so f is integrand, and dv means v is, and d is the object here, and v stands for the volume, so it's like this. And that can be written as integral, triple integral of dx dy dz. And by Fubini's theorem, we can always do the switching the order of dx dy dz. And the definition of this is defined by a limit of Riemann sum, which is if we can divide it into many small blocks, then that is approximation of this triple integrals, and the limit is exact number of this triple integral. And using with this definition, we can do a few application of triple integrals. So first of all, if we have an object, a 3D object, then what is the volume? Then the volume is basically looking at, suppose we have the certain object, 3D dimensional, then we want to put a lot of three-dimensional cubes whose face value is $1, and then you can collect them, which means this is the triple integral with integrand 1 and dv. So this is the volume, and we're going to look at first example. So here we say set up the limits of integration for evaluating the triple integral of a function f of x, y, z over the tetrahedron D whose vertices are 0, 0. So those 4 points. Use the order of integration dz, dy, dx. So here we again if there is a given order dz, dy, dx, then we're going to follow this. And to do that, first I'm going to recall what we have done in the last video. So in the last video, we introduced how to find out the equation of a plane going through 3 points. So suppose in this case, what we are going to do is, there was an example. So find equation of the plane going through 0, 0, 0 and 0, 1, 1 and 1, 1, 0. Then the answer is that x minus y plus z equals 0. It was, so if you do not remember, then you should go back to the previous video to find this out. It is very important and crucial for the computation of triple integrals. So our problem here is following. We have object of 3D object, and we want to do dz, dy, dx. So what does it mean? It means we first fix x and y. So we can, I can take this picture. So if we look at this picture, so we want, suppose D is the area, or not, this 3D object, the region, and then F is integrand and dV. I want to figure out those 6 values or expression under dz, dy, dx. So this is the given order we want to look at. So what we do is, first we fix y and x and look at dz. dz means differential of z. Basically, you want to know what is the change of z given xy. So we fix xy, and then we look at d stands for differential. So I want to look at the range of z. So that means we look, so xy is fixed at some point, and then we go along the z-axis and see when it starts and when it ends in the object. So this is z minus the lower limit, which is basically 0, z coordinate. So z minus is 0. This is simple. But what is z plus? Z plus, this comes from this point. This point is the red dot point is the last point going through the object. So this point is on the plane going through these 3 points, which is the plane given by here and the equation here. So what it means is z plus is from the plane of x minus y plus z equals 0. This is a plane. Then from here we can find, so if we solve for z from here, so by solving means, so z can be isolated from one side and x minus y can be moved to the other side. But when you move, you need to flip the sign. So z plus is going to be negative x plus y. So this is upper limit. Now we look at the range of, so now we want to look at dy. In this case, x is outside integral, so x is given. So if x is given, and can you look at the range of y? That's what it means. So instead of looking at this 3D object, for this, you're just focusing on x and y of plane, xy plane. So what we do is we can take out or the picture, the plane of this plane, xy plane, from this original 3D picture. This is much better. So in that case, this is 1 1, this is 0 1, so and 0 0. So there is a triangle 0 0 and 0 1. This is 0 0 and 1 1. And here 1 1. Yep. So the region we're looking for is this. Then that means when x is given, for example, somewhere here, then we're looking at the dy, so parallel y-axis. So we are going to put a stick here, and the point you are going, x minus, lower limit is here, and upper limit is here. So the lower limit is going to be from this line with slope 1, which is y equals x. So lower limit because y range. So I need to look at, I should look at what is y minus. Y minus should be from y equals x line. In other words, I can y is basically x when the red dot, and y plus is from this line, horizontal line. So basically, y plus is just 1, no matter what x is. It's horizontal, constant. Now for dx, finally we come up with the last integral, the most out integral. So for x range, we can see from here. So it's starting from this stick is moving from here, so 0 point, and all the way to here. So x is basically, x minus is 0 and x plus is 1. Now at the end we can write this answer based on our analysis. So x is from 0 to 1, and y is from x to 1, and z is, I need more space, so z is from this 0 to from this value, negative x plus y. And I will move this back. So this is what we wanted for this example. All right, next example. So it's just application of the previous example. Find the volume of tetrahedron D from example 2 by integrating f equals 1 over the region. So what it means is I want to do this calculation. I want to do this calculation with f is just 1, face value 1. And then the correct form of this is coming from here. So the computation. So we are going to compute this thing. This is too big. So we want to do 0, 1 and x1 and 0, negative x plus y, and f dz dy dx, but with f equals 1. Then the computation is doing repeating integral from very inner integral to the very outer integral, step by step. So first we do the inner integral. So outside I'm just copying down, and inside is just, if we do antiderivative things, it is basically negative x plus y. And then we do, now inner integral is dy term, so outside is not changing, and inside is antiderivative negative xy plus 1/2 y squared and x1. And if we calculate that, we can just put 1 for y and put x for y, and then take the difference. And after combining like terms and simplify simple algebra, so then we can end up with this integral. Now it's calc 1, entirely calc 1. So at the end we have antiderivative 1 half x, 1 half x squared, and 1 6 x third power, and 0 1, which is 1 6. So this is tetrahedron volume by doing triple integrals with integrand 1. So for the volume, we remember, if we recall the double integral application, for 2D object, you can talk about area instead of volume. At that time, we do double integral with integrand still 1. Now, the next application is average, right? So average value of f over d. So this is basically taking triple integral over d and then divided by the volume, the size of d. So here's another example. So find the average value of f given by xyz throughout the cubical region D, bounded by the coordinate planes, and the planes x equals to y equals to z equals to in the first octant. So this is about the cube bounded by with the side length 2. So if we do approximate picture, yeah, it's not a really good picture, but we can see that if the side length is 2, then we have something like this, d. So the volume of the d is, of course we can do the triple integral, but for this problem we do not have to. It's 8. But for the average, we want to find out triple integral of f over d, which is, for this cubic area, it is 0 to 0 to 0 2, and x, y, z, dx, dy, dz. Of course, if you want it, you can do dz, dy, dx. It's up to you, but essentially it gives the same calculation. So when I look at this integral, y, z's are constant, and this is 1 half x squared antiderivative, and 0 to dy dz. So we get 0 to 0 to, and this guy is 2. And now this term is, so 2z is constant, and y antiderivative is 1 half y squared, and dz. So we get 0 to, again, this term gives me 2, so 4z dz. And at the end, this is 4 times 1 half z squared 0 2, which is 8. This is not final answer. We want to find average, which is triple integral of f over d dv, and the volume of d, which is 8 over 8, 1. All right, that's the last example, and we're going to stop here.